In this session, we will learn how to calculate the highest power of a prime number in the expansion of factorial n. So far we have factorized normal numbers, that is decimal numbers, which are relatively easy to factorize. Now consider a case where we are given a number such as factorial 20 to factorize. Now how do you factorize a number like factorial 20? Our normal method of factorization will be very difficult to apply, because we need to calculate the highest power of 2, highest power of 3, highest power of 5 and so on in the expansion of factorial 20. So this method that I am going to describe will tell you how to calculate the highest power of a prime number that divides factorial n. Any basic book of algebra will tell you that the highest power of a prime number p, which divides a number such as factorial n, is given by this formula: I n upon p plus I n upon p square plus I n upon p cube plus and so on, where I of any number is nothing but the integer value of that number. So it represents the integer value of x. Ix represents the integer value of x. What is integer value? Let's take one sample calculation. For example, I want to calculate the integer value of 7 upon 3. So the first thing we do is we calculate the value of 7 by 3 in decimals. So we'll get I of 2.3333. So integer value of 2.33 is an operation which retains only the integer part of any number. In this case, the integer part is 2, so we retain only 2. So integer value of 2.3333 is equal to 2. Now let us solve one question which utilizes this formula. Find the highest number of 2 in factorial 20. It's a very simple formula where n is equal to 20 and p is equal to 2. So the highest power of 2 in factorial 20 can be calculated as integer value of n upon p plus integer value of n upon p square plus integer value of n upon p cube and so on. On putting the values, we get integer value of 20 upon 2 plus integer value of 20 upon 2 square plus integer value of 20 upon 2 cube plus integer value of 20 upon 2 to the power 4 and so on. So we get the value, we get this answer on simplifying as 18. But is there an easy way of solving this question than applying this formula? Let us see that easy way. Again the same question, to find the highest power of 2 in the expansion of factorial 20. So step 1, divide 20 by 2 as shown here. So 20 divided by 2, we get 10 as the quotient and the remainder is 0. Now divide the first quotient that we got, 10, by 2 once again, and we get the quotient as 5 and the remainder as 0. Divide 5 by 2 and we get quotient as 2 and the remainder is 1. Divide 2 by 2, we get 1 as the quotient and the remainder is 0. Now you can see that 1 cannot be divided, this 1 cannot be divided by 2 any further. So the process stops here. The next step that we are required to take is add all the quotients from 10 to 1. So all the quotients that are there below your original number 20, just add them up. So we add 10 plus 5 plus 2 plus 1 and that gives us an answer 18. So this is just a simple application of the previous formula. You can see that in the previous formula we had integer value of 20 by 2 which was equal to 10. Then we had integer value of 20 by 2 square which is nothing but 5. The third term was integer value of 20 upon 2 cube, that is 20 by 8, we got 2 and so on. So it is nothing but another representation of the previous formula. Let us solve one more question. To find the highest power of 3 in the expansion of factorial 30. Now we'll simply apply our method. Start by dividing 30 by 3. So 30 divided by 3 gives you 10 as the quotient and 0 as the remainder. Then 10 divided by 3 gives you 3 as the quotient and 1 as the remainder. And then 3 when divided by 3 gives 1 as the quotient and 0 as the remainder. Now this 1 cannot be divided by 3 anymore, so the process stops here. And the next step is whichever quotients are there below 30, add them all up. So below 30 we have all these 3 quotients, 10, 3 and 1. So we add 10 plus 3 plus 1, which is equal to 14. So the highest power of 3 in the expansion of factorial 30 is 14. Let us solve one more question. So is it possible to find the highest power of 10 in the expansion of factorial 250 by the same method? Now if I give this question in class, 90% of students generally reply in a yes, and in a hurry they will quickly start calculating by the same method. But you need to remember that you cannot find the highest power of 10 in the expansion of factorial 250 by the same method. The reason is our method is only useful for prime numbers and 10 is not a prime number. So we cannot directly apply the same method in the above example. So how to calculate the answer to the above question? Let us see that. The first thing is break 10 into its prime factors. In this case, the prime factors of 10 are 2 and 5. Then find individual highest powers for each of the prime factors, prime factor 2 and prime factor 5. Let us do that actually. To find the highest power of 10 in the expansion of factorial 250, first of all, I break 10 into its factors. 10 is equal to 5 into 2. And you may remember, to get 110, we need a pair of 5 and 2. So if there are 10 5s available and if there are 20 2s available, then we will only get 10 pairs of 5 and 2. So if you understand this, we can proceed to the next step. Step 2, find the highest power of both 5 and 2 in the expansion of factorial 250. So first of all, let me find the highest power of 2. 250 divided by 2 gives me 125 as the quotient. I am not interested in writing the remainders anymore because remainders are not required. 125 divided by 2 gives 62 as the quotient. 62 divided by 2 gives 31 as the quotient. 31 divided by 2 gives 15 as the quotient. 15 divided by 2 gives 7 as the quotient. 7 divided by 2 gives 3 as the quotient. And 3 divided by 2 gives 1 as the quotient, and 1 cannot be divided by 2 any further. And now the highest power of 2 in this case will be an addition of all the quotients from 125 to 1. So what is that addition? 125 plus 62 plus 31 plus 15 plus 7 plus 3 plus 1 is equal to 243. So we got the first part of our solution, the highest power of 2, which is equal to 243. What about the highest power of 5? The highest power of 5 can be calculated as 250 divided by 5 gives me 50 as the quotient. 50 divided by 5 gives me 10 as the quotient. And 10 divided by 5 gives me 2 as the quotient. So the highest power of 5, which can divide factorial 250, can be calculated as the addition of all those quotients below 250, 50 plus 10 plus 2, that is 62. So we have two values here, the highest power of 2 and the highest power of 5. The highest power of 2 is 243 and highest power of 5 in the expansion of factorial 250 is 62. So which implies that we have 243 number of 2's and 62 number of 5's. So how many pairs of 5 and 2 can we get? We can only get 62 pairs of 5 and 2. If you are unable to understand this, just imagine that there are 243 boys and 62 girls in your class. So how many pairs can you form? Can you form 243 pairs? No. You can form only 62 pairs. In a similar case here, when there are 243 twos and 62 fives, we can only form 62 pairs. And therefore, the highest power of 10 in the expansion of factorial 250 is 62. So with this, we come to an end of this session. In case you have any feedback or in case you have any query, feel free to write to us at studentservices@pfindia.com. Thank you very much.